Welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve Leetcode problem 1289 minimum falling path sum 2. Given an n by n integer matrix grid, return the minimum sum of falling path with non-zero shifts. A falling path with non-zero shifts is a choice of exactly one element from each row of grid such that no two elements chosen in the adjacent row are in the same column. Okay, if you have chosen one from the first row, that means you cannot choose 4 in the next row immediately. You can choose 5, you can choose 6, any one, any other number, any other column. Okay, now that let's say we have chosen 5, then we cannot choose 8 because this column is occupied in the previous row. Now we can choose between 7 and 9. Okay, given this constraint, you have to identify the minimum sum of falling path. Okay, let's just say we are standing at a grid I comma j. Okay, we are standing at I comma j. Let's just define a function called f of I comma j, which will tell me the minimum sum falling path from I comma j till the last row. Okay, so what all options you have? If you are standing in a particular grid, that means you cannot choose the same column in the next row, but you can choose rest all other columns. Okay, that means you have to get the minimum from rest all other columns to the end of the row. Okay, so that is what we are doing. Okay, and we should also take the current cell value. Okay, so the final answer will be a of I comma j, which is the current value, plus minimum of f of I comma k, where k is basically lies in the range of 0 to n, and it should not be equal to the j because we are in the jth column itself. Okay, if this is the recurrence relation, right? Now let's also define the base case. Now if we have reached the last, the last row, okay, that means there are no more rows to process. Okay, let's say we have reached the end of the grid, then we will be returning 0. Okay, if I is basically greater than or equal to n, that means we'll be returning 0. Okay, if we are going out of bounds of the grid. Okay, this is what the recurrence relation is. Or you can simply say if I is equal to n minus 1, then simply return the grid value also. Okay, that is also you can do it. Here I have taken I is greater than or equal to n, saying that if you are going a row which is out of bounds of this particular row grid size, then I will be returning 0 because there are no elements to consider. That is the reason I am returning it as 0. Okay, if let's write, if you draw the tree diagram for this particular recurrence relation, you will notice that there are certain problems which will be overlapping. Okay, if you see, 4 will depend upon this answer to this grid and answer to this grid. 5 will also depend on answer to this grid. Okay, so 4 is depending on answer to this grid, as well as 5 is depending on answer to this grid, because that means these two problems are depending upon this sub problem, right? So there are overlapping sub problems. Whenever there are overlapping sub problems, we will be using dynamic programming. That means we will be caching the answers which were already calculated and reusing them whenever it is required. Okay, so my final answer will be, I will be basically checking. Okay, I will be basically checking for each and every column in the first row. That means I will be starting in this particular cell and check what is the answer, and I will be starting from this particular cell and identify what is the answer. My final answer will be minimum of all of these answers. Okay, if I choose to start from all of these cells, what among all those answers, what is the minimum value, that will turn out to be my final answer. Okay, so let's just define my function f of I comma j. As I mentioned, if I is greater than or equal to n, then I will be returning 0. That means there are no more elements to consider. Okay, now at any given point, okay, I have to choose all the columns which is other than equal to the current column. Okay, so I will be defining a k which will start from 0 to 0 and go all the way up to the end. Wherever my k value is not equal to the current column, I will be finding answers to all those sub problems. Okay, so all the sub problems will be f of I plus 1 comma k, and I will be trying to minimize the answer. Okay, now that my answer to the current cell will be the current cell value plus answer to all my sub problems. Okay, since we have mentioned that there are overlapping sub problems, we will be storing the answers which were computed in a 2D array. So if you notice why 2D array, if you see j will go from 0 to n and I will go from 0 to n. So we need, there are total n by n unique states which will be forming. So we will be defining a 2D array of dp which will be of size n by n, okay, and we will be, if the answer to a particular state is already calculated, then we will be returning the answer, or else we will be computing the answer and storing the answer. Okay, now my final answer will be answer minimum of all answers coming from the first row. Okay, so that is what I am doing. I have defined a j which will go from 0 to n, and I will be finding answers to all those cells. Okay, and I will be trying to minimize it. So my answer will contain the final answer, which is minimum falling path sum. Okay, if you submit this problem, all the test cases will be passed, and it will be pretty efficient solution as well. Okay, now let's analyze the time complexity and space complexity of this top down approach. Okay, as you can see, we are populating, if you see, this I and j are taking states of I is going from 0 to n and j is going from also 0 to n. So there are total n square unique states, and for each unique state we are running a for loop inside it. That means the overall time complexity will be order of n square into n, which will be order of n cube. So the time complexity is order of n cube for top down approach, and the space complexity is, we are just using an extra space of order of n square, okay, which is basically the dp array. Okay, we just define an extra space of n by n matrix, so the space complexity will be order of n square. Okay, now this is what top down approach is. Okay, and we have used memoization for the top down approach. Let's see what is that bottom up approach. Okay, in the bottom up approach we will be having a dpr of size n by n, but we will be filling the values from the bottom. Okay, so first we will be filling the dp row n minus 1, we will be filling the n minus 1 row, followed by n minus 1, n minus 2 row, n minus 3 row, and so on and so forth up to the 0th row. Okay, and this is exactly same as the recurrence relation which I have mentioned. Okay, so for each cell value it will be getting the minimum value from all its next rows where other than the current column. So that is what I am doing. For the last row, the answer will be exactly same. The dp of last row will be equal to the matrix of the last row. So that is what I just define a variable remaining, and then if you see for the last row it will be just dp of grid plus remaining will be 0. So it will be exactly same values. For other than last row, the answer will be coming from all the cells where the column is not same. Okay, so we will be going from k equal to 0 to n, and then wherever my k is not equal to the current column, we will be taking all the minimum values from the next row, and then I will be adding to my current grid. Okay, and then we will be populating dp of I comma j. Whenever we are in the first row, we will be also keeping track of the minimum values of the first row, and then my answer will contain the minimum falling path. Okay, now if you see here, the time complexity is exactly same. Okay, we have 3 for loops. Okay, and which will be order of n cube, and space complexity is order of n square. Now we can actually do some kind of optimization in the bottom up approach. Okay, where the answer to each row is actually depending upon answer to the next row. That's it, right? So we will be not just the next row. That is what you can do. If you do that particular approach, you will be reducing the time space complexity from order of n square to order of n. Whereas if you keenly observe, okay, answer to any particular cell is depending upon the minimum value coming from the next row. If the minimum value is in the same column, that means we have to take the second minimum in the next row. That means at any given point of time, we need to keep track of what is the first minimum in the next row and what is the first second minimum in the next row. Okay, so that is what I am doing here in the optimal solution. Okay, So in the optimal solution, I've just defined f mean and f mean as the first minimum and s mean as the second minimum, and both are I've instantiated to the maximum values, and I've also defined the indices at which I've identified the first minimum and second minimum. Initially, I've just defined both of them as -1, indicating that I haven't computed the first minimum and second minimum. Now that I will be starting from the last row and propagating from last row all the way up to the 0th row. Okay, now for each row individually I have to calculate that particular row's minimum and the first minimum and the second minimum and the corresponding indices. So for each row I have defined a temporary variables which will keep track of the first minimum of that specific row and the second minimum of that specific row, and followed by the corresponding indices as well. Okay, now I will be moving from 0 to all the way till the end. Okay, I will be processing the columns in this particular fashion, and for the last row, if you see, the answers will be in the last row. I have to calculate what is the minimum, first minimum and the second minimum. Okay, if the grid value plus the remaining for the last row, the remaining will be 0, because the answers to all these cell values is actually the grid values itself. So among these all grid values, we have to identify what is the first minimum and second minimum. Okay, if the grid value plus the remaining, if it is less than the first minimum, that means we have encountered a value which is actually less than so far first minimum. That means first I have to check whether the first minimum is calculated or not. Okay, if first minimum is already calculated, that means the first minimum will become the second minimum, and the corresponding second minimum index will also be updated, and my first minimum will be updated to the new minimum value and the corresponding index as well. Now that if this summation, if it is greater than the first minimum, that means I have identified the second minimum, right? If first grid of I comma j plus remaining, if it is less than the second minimum and if it is greater than the first minimum, that means I have to update my second minimum. Okay, now that for a given row I have calculated my first minimum as well as second minimum, now I will be updating those values with my global minimum and global maximum variables. In the end, the moment I process my first row, that means my answer will be present in the first minimum itself, because in then I have to calculate the minimum. Okay, minimum path sum, right? So among all the answers to the first row, what is the first minimum is what my answer will be, right? So that is what the first minimum is. If you look at this particular approach, the time complexity is basically order of n square. Okay, because we are just computing in the each row what is the minimum, first minimum, and what is the first maximum. We are just iterating, and we are also not using any extra space at all, okay, other than some basic variables, right? So the space complexity will also boil down to order of 1, which will be constant space. So overall time complexity is order of n square, as well as the overall space complexity is order of n. Okay, so if you like the explanation, hit the like button and hit the subscribe button, and share your valuable feedback in the comment section. I will be posting the solution in the description as well as in the comment section. I will be providing it in multiple languages, Java, Python and JavaScript. If you are coming from any other languages also, feel free to check out the solution. The underlying logic will remain same irrespective of what language you are coming from. So that's all about this problem. Thank you.